we put it in E-stop at the end of the day. That way, if there's a slight air leak, it's not running overnight or anything like that. Pretty much every E-stop, if you're not used to them, reacts to a twist reset. Some of them are pull only, most are twist. To get this one to come back up out of E-stop, you press and hold this enter button for several seconds until it says a reset. You can let go. And then you need to press and hold this power button until a little icon comes up here that says it'll turn the motor on when it needs to. So now it'll run whenever the pressure drops too low. To turn the dryer on, because technically you're supposed to have clean, dry air running to most equipment, you just put this guy on, it runs, and it's drying the air that's going to the manifold. So once that's happy, I'll come over and I'll kick on air. Again, that's just this switch. You turn it to the right. There's some icons here telling you which way to turn it on and off.
Clockwise.
Yep. Sorry, it was already on for whenever I left it on.
Counterclockwise.
Yep. Turn that on. You'll see pressure here. You'll hear air running through there. If this has been sitting off for a long time, it'll slowly bleed out with just the way it works. So you'll hear that thing kick on and it's like pump, 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 pump.
Okay.
But otherwise, that tank always holds pressure. It just might slowly bleed off. So even if you're in E-stop, even if you've undone this, that tank still has pressure in it. So just be aware. Shouldn't need to mess with it, but it does have pressure. That's it. Don't need to mess with anything else here. Just turn that on. Make sure it's got pressure. If you do, come over to the clean disconnects. Turn this both on. And just as a note, so if you're ever doing anything, I don't know why you would be, but if you're ever doing anything maintenance-wise, there are lockouts for all the power sources. So there's lockouts. So you can get these lockout tag-out locks. You can lock them out in the position there. You come over here. This has a lockout as well. If you pull this little thing out here, then it won't be able to come on. So there's a couple of things you can do. Just so you're aware. But those are on in general. When you turn these on, I kick the spindle power cabinet on first and then the robot. It shouldn't really matter. There's the one caveat is if for some reason you have the robot on for an extended period of time without the spindle cabinets on, the robot will show an EtherCAT communication error that is not clearable unless you power cycle the machine. If you have this off for, I don't know how long it is, it's like a 2 or 3 minute timeout. After it gets past that point, it wants a power cycle. If you just disconnect the cabinet for a little bit and then plug things back in, it's happy. But it's not happy without the communication running for a while. So it'll show up with errors indicating such. It takes a little while for the PLC to turn on. You'll hear a thunk in this cabinet when you power it on, and also when if you push code or do anything to the PLC, because the PLC has control of a main contactor that's running, that delivers 480 volts to the spindle drive. Our PLC. Well,
if we have a bug or something.
It's like what I'm giving you is everything that the robot is running. Like our compensation PLC is just the compensation. The PLC that you guys have access to
has everything else.
Has everything else. Okay. So you guys can change I/O, you can change anything that we've done in there for the controller.
Okay.
But just be aware, the thunking that you're hearing in here is that main contactor turning on and off to deliver for you. It takes a while for that thing to boot up. sequence. Once it is booted up, you'll have a bunch of, well, several messages here. The mastering test and the brake test required will happen, I believe, at every power on. So if you guys want to leave the robot running, it's kind of annoying. I mean, it does use power. But if you don't want to have to run the mastering and the brake test every time, yeah, I think you have to leave the power. Cold start of the controller is just telling you we just powered it on. Robot stopped by submit. That is a message that just said, as things were turning on, messages that we had coming from the PLC side just halted the robot until all the communication was up and running. So you can confirm that. You can confirm all of them. These ones stay until we run those tests. There is one message here that you'll see a lot, which is jog velocity disabled until tool is selected. This is one that we added specifically because when you start the robot or when you reset or cancel out of a program, your tool selection is in this upper right hand corner. This is what base coordinate system your robot is running in currently, in jog mode anyway, and what the tool selection is, so what the end effector selection is. They start up with a null. And the annoying part about the null is it has no mass and it has, it's got the default flange coordinate system. So as a safety mechanism, because our end effector coordinate system is different than the default flange coordinate system, we set the jog velocity override to 0 unless you have a tool selected. And what this is a catch-all, because I've done it myself and it's a huge pain. If you select a program, this is just as like a quick why we do this, and you run that program, it's not going to move the robot.
Because it's disabled.
We just told it that it has tool 1 active programmatically, okay? So now you see tool 1, base 0, okay? All right, I'm doing something with the robot, messing around. Oh, I need to jog the robot for a second. Let me just reset out of the program and it goes back to a null frame immediately, and now you're jogging in a different coordinate system than you were jogging in 10 seconds ago.
Okay.
So, as a reaction to that, we set the jog velocity to 0, so then you're sitting there and you're pressing the button and the robot's not moving and you're like, what the hell? Well, it's because we want you to select the tool
Before you do the
you
jog.
know what coordinate system you're definitely jogging on before you do that. Now, you're not always jogging in the tool coordinate system, but it's a protection for when you are, because it's very convenient to jog in the tool coordinate system to make sure you have the tool selected. Because otherwise, if you hit that reset button and then jog the X direction, it's a different X direction than what you thought.
Okay.
So that is there until a tool is selected. It'll get annoying that it's always there, but it's definitely, like, it's a safety. It'll save you from crashing the robot for sure.
And then the base coordinate system, always just standard base.
So you can set up different base coordinate systems. So like if you guys, and you can select them programmatically. So it starts with a null frame, which is the unknown, okay? Or the null frame, right? The standard base is one that's just we named it standard base, but it's the typical base coordinate system that's like located at the base of the robot, XYZ. You can define other ones and you can select them programmatically if you guys want to. Like, it might be convenient for you guys to, once you get your mill table in here, to store the mill table transformation as a base that you can then just select. So that will then change the XYZ coordinate system. So, you know, in a part program, basically the way it works is you will select the tool, select the base, select the load for your end effector, the base that you're programming in. Then all your Cartesian coordinates are in that frame. And then if you want to switch to a different frame, you call that different frame. Now XYZ is in that coordinate system. You know, so yeah, that's what the base is you can change the base coordinate system if you want to. And that's the same as jogging as well. If you have an active base that you're jogging in, then that's a different coordinate system is jogging.
So for the jogging, I guess warning, you should set both the base and the tool, right?
The base doesn't matter as much because the default jogging mechanisms are base, tool, axis, world. So like a null base is the default base.
Okay.
Okay,
Gotcha.
but a null tool is a different coordinate system.
Yeah,
than
gotcha.
Okay.
Okay.
So, yes, the base could cause you issues too, but it causes less issues than the tool, in our experience. So we'll walk through safety stuff here. E-stop. Twist to undo the e-stop. The operator enable switches. So when you're in T1 mode and everything's happy, you press the operator enable switch. Everything goes green. These two go green up here, indicating that the safety system, that the submit interpreters are happy, and this is all the safety checks for being able to enable the robot drives. You'll get green lights over here. You'll hear the air kick on whenever you do that. If you let go of it, the air stays on, but the air will turn off when you hit the e-stop button and then not come back on until you until you confirm that you hit the e-stop button and you depress the switch. So in general, the robot standards always want 2 button presses minimum to re-enable energy to the system. And that's because people have died whenever you've done, if you have anything that re-enables motion of the robot based on a switch, you want to have somebody have to press a button. So, there's been people who have died from things like if the door closes, robot motion starts again, and so somebody accidentally closed the door and somebody was still in the cell. So, a lot of these messages that you see, like when I hit e-stop, and then I undo the e-stop, it'll say acknowledge emergency stop. It won't come back up until you click the button saying, okay, I know, and then now it'll come back up. So there's a multi-step process.
Is that the same thing as the green button?
The green button's different. We'll go over that. But in general, I know that you get a lot of messages and a lot of confirms, but that's all because it's for safety and for these like multiple button presses to try and resume motion. So, let's see. Where should we go from here?
I think Russ was recommending that we keep the robot on at all times, right? Yeah.
Leave it on, turn it on.
Yeah.
Yeah, I mean it's not a bad idea. It does pull some power. It's not a ton of power. The minor annoyance is that the gremlins. Anytime you turn something off and turn it back on again, but the brake and the brake test and the mastering test, they will come back on power on, and then you'll have to rerun them.
Yeah.
If you leave it on, then there's like a 48-hour or 76-hour or something timer for each one, and then you'll have to run them every few days.
Okay.
So let's do that now to get rid of all of these alarms. So robot standard. Everybody that's in the cell must have an enabling switch. We didn't give you guys every extra enabling switches, so in general, I know it's like impossible to do at all times, but in general, don't run the robot with 2 people in here. There's plenty of space here for you and great visibility for most stuff. You guys can run it from outside the cell. If you do need to be up close and personal with the robots, 1 person with pendants with safety glasses if you're running with the spindle. So, and let's all